So we always look for the GCF first. So here's a couple of quick examples. Number 1, 4x squared plus 8. The very first thing you would do when you're going to go factor is to look for the GCF. What is the GCF here? 4. Okay, so I factor out the 4, and what do I get? X squared plus 2. Okay, if you could still factor something else out of here, then it's not the GCF, it's just the CF, right? We want the greatest common factor, and that is it. Factoring out the GCF is just the opposite of distribution. We understand that, right? Because if I distribute this back in, that's what I should get. Okay, so number 2. Come on in. Here you go. Just grab a seat somewhere. Here's your paper. Okay. All right, so then we have 10x squared times y plus 25xy minus 30x. So on this one, what is my GCF? 5x, right? So if I factor out my 5x, that leaves me with 2 what? X, y, plus 5y minus 6. Okay? Everybody okay with that? And then, these are going to factor any farther, but then if we could factor farther, then we would do more. But GCF first. Okay? If you feel like your numbers are huge and things look weird, ask yourself if you actually looked for the GCF, because sometimes we just forget that or didn't recognize that there was one. Okay, so now you're going to the box right below it. Okay. Second box on the front. And if I have an equation that looks like this, ax squared plus bx plus c, what is that called? What kind of equation? It is a trinomial, yes. Oh, very good. It is a trinomial, and because we have that x squared, that makes it a quadratic. So it's a quadratic trinomial, yes. So quadratic is what I was going for, because for whatever reason we have trouble with that word. So quadratic. So when we're talking about factoring quadratics that are in this form, right? When we factor this, if it's factorable, because it may not be, we check for the GCF first, and then when we factor it, if it's factorable, we can factor it into 2 binomials, right? And these things right here are called the factors. For some people, the concept you get, and you understand what you're supposed to do with the numbers, but then the signs just mess everything up for you, and sometimes you just get lucky and it works out for you, and then other times weird things happen and you don't even know what's going on. And y'all don't always check yourselves to make sure it factors back. When you have an equation like this, all right, this c could be positive or a negative. So we're going to look at what happens if I have a positive c or if I have a negative c. And I say this stuff a lot, but I'm not sure all of you are like following what I mean by it, or you're not thinking through it yourself when you're doing it, and that's why things are getting mixed up. So if I have a plus c type of situation, then that means my factors have the same sign. Oh, wait, factor signs, that's what I should do. I can write less words there. Factor signs are the same. What I mean by that is the signs that go in here. Right? If you can decide on those signs before you start, that's good. The factor signs are going to be the same. Well, when I have a positive c, 2 different things could happen with b. I could have a positive b, or I could have a negative b. So by the signs being the same, that means it's plus plus or it's minus minus. Well, if b is positive, then what is it? Plus plus or minus minus? Plus plus. So it would be plus plus. If b is negative, then it's minus minus. So once you've decided on your signs, then that can help you with which factors actually work in there. We good with that? If my c is negative, okay, if the c is negative, then your factor signs are different. And again, with a negative c, I could either have a positive b, or I could have a negative b. Well, on both of them, the signs are different. So it's plus, minus, plus, minus. Well, I need to distinguish between the two, right? When the signs are different, but your B is positive, which one's bigger? Positive or negative number? Positive. If your B is positive, then the positive number is bigger. When the signs are different and B is negative, then the negative number is bigger. Okay. So I want you to have this to refer back to if you need to, but at least those thoughts should be going through your head so that you can make sure the signs are right before you worry about numbers of any type. Okay, we good with that? Any questions? All right. So now if you open it up, you're going to go to the top left box. We're just going to fill in these 4. That's it. Okay. So I'm going to give you one. This is number 3 then. And we have x squared minus 11x plus 28. Is this a pretty easy thing to factor? Would you say? Yes. And last time y'all were in here, we factored a lot of these, and y'all did pretty okay with them, right? So we'll just factor this one together real quick. We're looking for 2 numbers that multiply to give me 28, right? Okay, and this is plus. That means the signs are the same. This is negative, so that means they're negative, negative, right? And so what are the 2 numbers? 7 and 4. And it's easy, right? No big deal. That, I think you're fine. You can check yourself, though. If you're unsure, make sure these actually multiply to give you that number with the correct sign, and that when you multiply these 2 together, they actually combine to give you that. And you don't have to write anything else out to check yourself, but you can check yourself. All right, so then let's look at this one. So for number 4, we got 2x squared minus 5x minus 63. Now, when a is not 1, most of you did okay on that too. Some of you kind of forgot a step. But regardless of whether a is 1 or not, when they're simple, basic numbers, you don't have a problem. Sometimes it's not the factoring you get lost in. It's the actual multiplication of the numbers themselves coming up with the right numbers, right? You understand the process. It's coming up with the numbers. So I'm going to show you a better way to go about that. But here, since I have this, yes, there's a divide and slide way. If you struggle with factoring at all, I would not suggest that way. Grouping is really the best. So before I worry about what my factors are, do we all understand what I mean by grouping at least? We've looked at that before. Okay, so when I split, that means I'm going to have to split this middle term. So I'm going to have 2x squared. Now, this is a negative c, right? Which means that my factors have opposite signs, right? So that means I'm going to have plus some sort of x that I don't know yet, and minus some sort of x, and I'll go back and fill in that blank, and then minus 63. So I have decided on my signs before I've done anything else, right? So to figure out what those numbers are, what do I multiply? A and C, good. 2 times 63, and that's going to give me 126, okay? And I'm going to, yeah, negative. And I'm going to not even worry about the sign at this point. Okay, I just 126, because I have my signs taken care of over here. If you want to write negative 126, that's good too, so you don't get lost. But then I'm going to list out my factors. Now, you don't want to miss the easiest obvious one, 1 times 126, right? Sometimes we forget that that's an option. Then what's another really obvious one? 2 and 63, right? So then, instead of guessing and checking, think about it this way. I could factor this number all the way out. We're not going to, but I could. This is not an even number, so I can't divide this by 2, right? But could I divide it by 3? Yes. So when I divide 63 by 3, what do I get? 21. So I'm going to write a 21 down here. Since I divided it out of this number, I'm going to multiply it by this one and get 6. So guess what? 6 times 21 is 126. Do you see what I just did there? Instead of guessing and checking and figuring out if it divides, now, I still can't divide this by 2. Can I divide this by 3? Yes. So what do I get? 7. Then I take that 3 that I divided out, multiply it by 6, and I get what? 18. And 18 times 7 is 126 without me having to actually do that at all. Now, the only thing I can divide this by is 7, so I would get 1 here, and then I would just get this factor back, okay? Now that I have those, it's not necessarily all of them. Since the signs are different, that means they're going to have to subtract to give me this 5, negative 5. Do any of those work? No, which means it's not all of the factors. That's okay. I'm still not guessing and checking. Because what I did is I didn't start with this one. I started here at 2, right? So all of these have a 2 in there. So let's just take the 2 out. Let's take this right here. All right, we'll take the 6. If I divide the 6 by 2, what do I get? 3. So this is going to be 3. Then I multiply the 21 by 2 that I divided out. What do I get? 42. So 3 times 42 is 126. I can take 18 and divide it by 2. I get 9. And then 2 times 7 is 14. You with me? You see how easy that was without this random guessing and checking when your numbers get bigger? Because I really think for some of you, the concept makes sense. It's coming up with what the heck it is that you just get lost in, okay? And you don't have to be a math whiz that can do it all in your head, but the process so you don't miss any of them, they're not in order. Nobody cares, right? Do any of those subtract to give me the negative 5? 9 and 14. And since it's a negative 5, that would be a negative 14 and a positive 9, right? So when I come to place it in here, that's a positive 9x and a negative 14x. Okay? So it's all about process. Sometimes they're quick and you can fly through them. Sometimes you got to slow down for a second to make sure you have everything in there you need. We all good? So then the next thing I do is what? Okay, yeah, I have to do the grouping, right? So I'm going to group these 2 terms and these 2 terms. So I factor out the GCF of these 2 pieces, which is what? X. So I get x times 2x plus 9. Then if this one is negative, I got to make sure I factor out a negative. Now, if you're not sure about the whole 14 and 63, whatever I get in the parentheses over here, shouldn't it match this? So I'm thinking I can only factor out a 7, a 2, or a 14. Well, the 7 would make the most sense to leave that in there. So I factor the 7 out. That leaves me with a positive 2x. And since I factored out the negative, that's a positive 9 because 7 times 9 is 63. Everybody good so far? Now we have this common binomial factor that factors out. And we get 2x plus 9 times x minus 7. And it's factored. Okay, we good? Any questions? That helps some of you a little bit? At least one step in there, whether, because again, I think for most of you, this process, you're okay. But what happened, I saw in some of your papers when y'all were when some of y'all were doing the extra ones where A was not 1, you came up with these numbers, but then you left me with like x plus 9 and x minus 14, and it didn't multiply back. But if I multiply this back, I should get this. Okay, we all good with that? All right. So next little box then, number 5. Okay, and we're not actually gluing this in anywhere. So if you like got off on your boxes, you need an extra one. It's not the end of the world. You'll be able to write on the back. X squared minus 16. Now some of y'all have already reviewed this in class, and some of you haven't reviewed this in class yet. But what is this called? They are both perfect squares, but the perfect square trinomial is different than this. We're subtracting them, so it's called the difference of squares, right? Difference of squares. Because just because it's a perfect square doesn't mean I can do anything fancy to it. Because if that was x squared plus 16, I couldn't do anything. But your difference of squares is a squared minus b squared would equal a plus b times a minus b. So it's very easy. This pattern comes up a lot. So we got to make sure that we know x squared plus 16. So the addition, the sum of squares is prime. You can't do anything with it. But the difference of squares, I can. All you have to do is be able to take the square root of both of these, and you get one of them is positive and one of them is negative. So x squared is x. I'm sorry, the square root of x squared is x. Square root of 16 is 4. And you're done. See how easy that is? That's a pretty easy one. Quick reminder about that. So let's do number 6. 25 minus 9x squared. Is that a difference of squares? Yes. I can take the square root of both of these terms. That's all that matters. So it's a plus and it's a minus. When I take the square root of the first term, what do I get? 5. So 5 goes in the front of both of them. because you can't mix this around or then the negative one is wrong. Then what's the square root of 9x squared? 3x. And you're done. See how easy that is? It's not bad at all. We can do this. Okay, everybody okay? All right, number 7. So next box. You can go to the top right box there. If I give you x cubed plus 8. And I know, again, some of us have reviewed this in class already and some of us haven't. But what is this called? They're not perfect squares, right? Are they perfect cubes? Yes. Are both of them? Yes. And what are we doing to them? We're adding them. So this is called the sum of cubes. So in preparing for this lesson today, I was like, okay, I don't want to just show them the pattern. I want to teach them why it is what it is. And from everybody I've asked and everything, there's no way for me to do that. It's just one of those, this is the pattern because I said so. And I don't really like the because I said so things. I mean, I can show you how it multiplies back, but that doesn't really show you why it works. But if I have a cubed plus b cubed, right? That's 2 perfect cubes. Those are the sums. So that's going to equal, here's what the pattern looks like, a plus b times a squared minus a times b plus b squared. So for those of us that have reviewed this in class, what's the acronym that goes with sum and difference of cubes? SOAP. Okay, good. So if you're like, what the heck, I don't know why you're saying that. This sign, when you do this, the sign is always the same. This sign is always the opposite. And this sign here is always positive. So if you can remember the A and B pattern that goes in here, this is where SOAP comes from. Same, opposite, always positive. That acronym can help you get the signs in the right place. So if I'm factoring the sum of cubes right here, then when I do this, I know I'm going to get a binomial and a trinomial. My signs look like this. It's the same sign as what I'm factoring. It's the opposite sign, and then it's always positive, and then I fill in the rest. I have to take the cube root of x, which would just make this equal to x cubed, right? What's the cube root of 8? 2. So this would be 2 cubed. So in here I get x plus 2. This is that first term squared. The middle term is these two multiplied together. And then the last term is the second one squared, which is 4. Okay, everybody good? All right, so let's do another one. X cubed minus 27. Is this the sum of cubes? Am I adding them? No. This is the difference of cubes. But the A's and the B pattern is the same. The SOAP helps you get the sign in the right place. So binomial, trinomial. My signs are the same, opposite, always positive. Cube root of x cubed is just x. What's the cube root of 27? 3. So that means this is x squared. This is 3x. And the last one is 9. Everybody okay with that? Any questions at all? Okay. Last box then. 40x cubed plus 15x squared plus 48x plus 18. So if factoring is not your favorite thing to do, then things like this that you're supposed to factor gives you anxiety before you try to do anything, right? You have to learn to stop doing that to yourself. You can't just look at things and let your brain shut down, okay? Just because it looks crazy does not mean that it's difficult. It does not mean that you can't do it. Now, is this a special case? The answer is no. The only cubes that are special cases are sum and difference of cubes. If you have something that's bigger than a trinomial, then your first line of defense is, first of all, to always factor out the what? GCF. Okay, so can I factor out a GCF? No, because so if you look at the smallest number, my options are 3 and 5 here. Well, I can divide this by 5. I could divide this by 3. Can I divide that one out? But I can't do 40 by 3, right? So since I can't do all of them by 3 or all of them by 5, I can't factor out a GCF. And that's how you can kind of tell. All right, so that's okay. Numbers are still not as small as we'd like them, not the end of the world. So then your second line of defense is grouping. I have them in descending order, which is the best way to start here. And then we just do grouping, just like when we had 4 terms with the quadratic. No big deal, right? Of the first 2 terms, can I factor out a GCF? Yes. What do I factor out? 5x squared. That leaves me, what? 8x plus 3. Okay. Out of the second 2 terms, can I factor out a GCF? Yes. What is it? 6. So this would be a positive 6. So that leaves me with 8x plus 3, which is good because these 2 binomials should match. If they don't, something weird happens somewhere. I factor out that common binomial, and then that leaves me with 5x squared plus 6. And then I always look to see, can I go farther? Well, this one I obviously can't factor any farther. Can I factor this any farther? Nope, I am done. That is it. See how it wasn't that bad? It's not that bad. But the basic rules of the signs and knowing how to get your factors, I think that's honestly where most of you get tripped up, or just letting stuff like this make your brain shut down, right, which we got to stop doing. Okay, any questions at all? Did any of this help at all? Maybe you didn't need all of it. Hopefully something, at least you feel a little bit more comfortable with it. Okay, good.